Hi, in the last video we have seen the definition of differentiation, the power rule and algebra of differentiation. Let me recap the power rule once again, then I'll explain you how to find the differentiation of the trigonometric functions. What is the power rule? Suppose you have a function x power n, the derivative of x power n is n times x power n minus 1 is power rule. So what are the observations derived from this power rule? The observations are, suppose if I have a constant function, what is the derivative of constant function? Take a constant function, let it be x. Okay, sorry, the derivative of constant function is 0. The second observation is, suppose you have k times any function. If I would like to find derivative of k times any function, it is same as k times derivative of that function. And the third thing is, what is the derivative of linear function? Like, for example, you take it as 3x plus 7. What is derivative of 3x plus 7? It would be 3 times derivative of x plus derivative of 7. We know derivative of 7 is 0, derivative of x is 1, 3 times 1 is 3, 3 plus 0 is 3. So the derivative of linear function would be coefficient of x, and the derivative of constant is 0, and the derivative of k times a function is k times the derivative of that function. Let me solve an example so that we are clear with the power rule, then I'll start explaining you how to find the differentiation of the trigonometric functions. For example, take a function f of x, which is 5 times x power 100 minus 7 times x power 30 plus 117x. I would like to find the differentiation of this function, that is d by dx of f of x, which would be same as the d by dx of the given function, which is 5 times x power 100 minus 7 times x power 30 plus 117x. In earlier video, when I explained you algebra of functions, we have learned derivative of f of x plus g of x is derivative of f of x plus derivative of g of x. It is not only required to have 2 functions, you might have 10 functions, 20 functions, 100 functions, whatever it might be. If it is sum of the functions, derivative of the for f of x plus derivative of second function plus derivative of third function. If you have a minus sign, just replace derivative of f of x minus derivative of g of x. So we can apply the sum and the addition or subtraction not only for 2 functions, you can apply it for more than 2 functions. So I apply the same rule here. It gives us derivative of 5 times x power 100 minus derivative of 7 times x power 30 plus derivative of 117x. Derivative of constant times any function is constant into derivative of that function, that is 5 times derivative of x power 100 minus 7 into derivative of x power 30 plus 117 into derivative of x. So 5 into derivative of x power 100 is 100 into x power 100 minus 1, that is x power 99, minus 7 into 30 into x power 30 minus 1 plus 117 into derivative of x would be 1. So this would be 500 into x power 99 minus 210 x power 29 plus 117. The derivative of this function can be found out without using this power rule. I can use the first principle or the differential coefficient and find this. Then it might have become too tedious. The calculation would be too tedious and there is a lot of scope to make mistakes. So what we should get from this problem is, whenever we are using the basics, we need to derive something. Here, using the first principle, we have derived the power rule. Using the power rule, I am solving this problem. Calculus is so simple. Just remember the important derivations which you have derived and start applying that. Then calculus would be very easy to solve any problem. Hope you are very clear with the power rule. Once you are clear with the power rule, I will explain you how to solve differentiation of the trigonometric functions. Now we shall start with trigonometric functions. So we do have 6 trigonometric functions: sin x, cos x, tan x, cot x, secant x, cosecant x. So trigonometric functions. Let me do derivation for 2 to 3 functions. For rest of the functions you can do derivations if you would like to have. But you should remember the output of this derivative. So take a function y is equal to sin x, or f of x is equal to sin x. I would like to find dy by dx. What does the first principle says? First principle is limit h tends to 0 f of x plus h minus f of x by h, that is equal to limit h tends to 0 sin of x plus h minus sin x by h. What is the formula for sin c minus sin d? Limit h tends to 0, sin c minus sin d is 2 cos c plus d by 2, that is x plus h plus x by 2 into sin of x plus h minus x by 2 by h. So this would give us limit h tends to 0 2 times cos of 2x plus h by 2 into sin of the positive x and the negative x gets cancels. We are left with h by 2 by h. So multiply with the 2 and divide with the 2. This 2 and 2 gets cancels. Now this can be applied as limit h tends to 0 sin of h by 2, sin of h by 2 by h by 2 into limit h tends to 0 cos of 2x plus h by 2. We have learned in limits, limit x tends to 0, sin x by x is 1. Similarly, here limit h tends to 0. If h tends to 0, definitely h by 2 also tends to 0. Limit h by 2 tends to 0, sin of h by 2 by h by 2 is 1. So therefore limit h tends to 0 sin of h by 2 by h by 2 into limit of h tends to 0 cos of 2x plus h by 2. That would be same as, just replace h with 0 in this cos, 1 into cos of 2x plus 0 by 2, that would be cos 2x by 2 The 2 and 2 gets cancelled, so we are left with cos x. So the derivative of sin x is cos x. So the second formula after the power rule is derivative of sin x, which is cos x, which is very clear, and I hope you should remember this too. So we have learned the power rule, and next thing is we have learned how to find derivative of sin x. Now let me show you how to find derivative of cos x. Derivative of cos x. Derivative of cos x is same as limit h tends to 0 cos of x plus h minus cos x by h. What is the formula for cos c minus cos d? Cos c minus cos d is minus 2 times sin of x plus h plus x by 2 into sin of x plus h minus x by 2 by h. Limit h tends to 0. The same thing can be written as limit h tends to 0 minus 2 times sin of 2x plus h by 2 into sin of h by 2 by h. Multiply with 2 and divide with 2. This 2 and 2 gets cancels out. So we are left with limit h tends to 0, minus is also there, sin of h by 2 by h by 2 into limit h tends to 0 sin of 2x plus h by 2. So we know this is 1 minus 1 into, just replace h with 0, I get sin of 2x plus 0 by 2, that is same as sin of 2x by 2. The 2 and 2 gets cancels here, so I am left with minus sin x. So the next formula is derivative of cos x is minus sin x. Next, let me derive, let assume f of x is tan x. I would like to find the derivative of the function which is tan x. So derivative of tan x is given as, I can use same first principle of the quotient rule here, but if we are, remember that tan x can be written as sin x by cos x. Why can't I use quotient rule? As I said earlier, anything becomes very easy if we can identify the best way to solve a question. So since tan x can be written as sin x by cos x, it is same as sin x is a function which is f of x and cos x is a different function which is g of x. It is same as quotient rule, derivative of f of x by g of x. What would be derivative of f of x by g of x? Cos x, that is second function, into derivative of the first function, that is derivative of sin x, minus sin x into derivative of cos x divided by cos x whole square divided by cos x whole square. So we know derivative of sin x is cos x, so the numerator becomes cos x into cos x minus sin x into, we know derivative of cos x is minus sin x by cos square x. So from this we should get cos square x plus sin square x divided by cos square x. So derivative of cos square x plus sin square x is 1 by cos square x is secant square x. So the derivative of tan x is secant square x. So let me recap the formulas what we have learned. One is derivative of sin x. The derivative of sin x would be cos x. And the second thing is the derivative of cos x. What is the derivative of cos x? Derivative of cos x is minus sin x. Then we have learned derivative of tan x. Derivative of tan x is secant square x. And then we have learned derivative of cot x. Derivative of cot x is minus cosecant square x. So then we have derivative of secant x and derivative of cosecant x. Then is we have derivative of secant x. What is the derivative of secant x? Secant x into tan x. And we have derivative of cot x. So if you look at this whiteboard, what can you observe from what I have written? Derivative of cosecant x. Derivative of cosecant x would be, derivative of cosecant x is minus cosecant x into cot x. Derivative of cosecant x is minus cosecant x into cot x. What can you observe from what I have written on whiteboard is the derivatives of all cotangent functions like cos x, cot x and cosecant x is negatives and these are positives. So this will help you a lot to remember this differentiation functions. There is no confusion anymore. So derivative of sin x is cos x, derivative of cos x is minus sin x, derivative of tan x is secant square x, derivative of cot x is minus cosecant square x. Derivative of secant x is secant x into tan x, derivative of cosecant x is minus cosecant into cot x. Just remember, so far we have learned 7 formulas, power rule and the derivative of these trigonometric functions. So far what we have learned, I'll just give you some few questions. I'll explain you some 4-5 examples so that you get clarity on what we have discussed so far. Okay. Now let me solve some examples. Take a function f of x. Let f of x be phi tan x minus cos x. I would like to find derivative of this function. Derivative of f of x is same as derivative of phi times tan x minus cos x. We know that I can write derivative of f of x minus g of x is derivative of f of x minus derivative of g of x. So this becomes derivative of phi times tan x minus derivative of cos x. Derivative of phi times tan x minus derivative of cos x. And we know derivative of k times f of x is phi times derivative of tan x minus cos x. It is cos x. It would be cos x. And we know derivative of cos x is minus sin x. Phi times derivative of tan x is secant square x. Phi secant square x plus minus of minus would be plus sin x. So this would be the derivative of the given function, which is phi times tan x minus cos x. Now let me solve the second example. Take for example f of x is x square by sin x. I would like to find derivative of the function f of x is x square by sin x. So the derivative of the function f of x is given as derivative of x square by sin x. Now this is again quotient rule. Very good. What does the quotient rule says? Sin x, that is second function, into the derivative of the first function, that is derivative of x square, minus x square into derivative of sin x by sin x whole square, or the same thing can be written as sin square x. So sin x into derivative of x square is given as 2x minus x square into the derivative of sin x, which we know which is cos x, divided by sin square x. So the derivative of x square by sin x is same as 2x sin x minus x square cos x divided by sin square x, which is the derivative of x square by sin x. Let me solve and show you a third example so that you get more clarity on this. For example, take a function f of x, which is root x times sin x plus 2 times tan x minus cot x. So if I would like to find derivative of this function, derivative of f of x is same as derivative of root x into sin x plus derivative of 2 tan x, which would be 2 times derivative of tan x minus derivative of cot x. So root x, now I can apply the chain rule here. Derivative of root x is 1 by 2 root x into sin x plus root x into derivative of sin x would be cos x plus 2 times derivative of tan x is secant square x minus derivative of cot x is minus cosecant square x. Minus into minus becomes plus cosecant square x. This would be the derivative of the function f of x is. So just to recap, you have learned the power rule. The derivative of power rule is n into x power n minus 1, and we have learned the derivative of all six trigonometric functions. So derivative of sin x is cos x, and derivative of sin x is cos x, and derivative of cos x is minus sin x, and derivative of tan x is secant square x, and derivative of cot x is minus cosecant square x. Derivative of secant x is secant x into tan x, and derivative of cosecant x is minus cosecant x into cot x. I shall see you in the next video with I'll explain you how to find derivative of inverse trigonometric functions, logarithmic functions, and exponential functions. But from these two videos, you are clear how to find